with our introduction to trigonometry today, introduction to trigonometry, give me a big set of axes here. We're going to put a bunch of stuff in this to understand what we're talking about with trig. Trig is based on angles. Trig is the study of triangles, and triangles are the basis of what trigonometry is studied for. Right? We have sine, cosine, tangent. When we have SOHCAHTOA, opposite and hypotenuse and adjacent and all this business. First thing I want you to do is first to label your quadrants. Upper right is quadrant 1, and quadrants, as you know, is notated with Roman numerals. Down here is III, which is 3, and here is IV, which is intravenous. Or, you ever have an IV at the hospital? IV, 1 comes before 5, where I means 1, V means 5, 1 comes before 5, so you subtract. 5 minus 1 is 4. This is quadrant 4. No, it's that's how you say IV.
Okay.
It's IV, quadrant IV. You should say quadrant 4. If I take an angle, let me label a couple things on here. Your side, start here at the origin and bring this out to the right-hand side, is my first side of the angle, and your book calls it the initial side, which I like, because sometimes your initial side is not always on the positive x-axis. Usually it is, and you can center it so that it is. Bring an angle up in this direction, all right, somewhere in quadrant 2. This is called the terminal side. Terminal meaning terminate, and terminate meaning to finish. That is, you see the movie The Terminator? What was his job to do? It was to come back and terminate the guy that owned Dyson Company.
Dyson.
Okay? I'll say it again? Alright. Now, if you have a value, if we start here at the initial side and go in this direction, okay, what you are going to have is a positive degree measurement. And let me notate it this way. If your angle is going CCW or counterclockwise, you will have a positive angle. A positive angle. We're not going to quite get into the sine, cosine, tangent business today, but we're going to start talking about radians, okay, and degrees and how to convert between the two. And obviously, if you go in this direction, you have your degree, all right, which is a negative number because you are going clockwise around the circle. You're going clockwise around the angles. Okay? And then we have this value right in here, which is the point or the corner of the angle, also called the vertex. The vertex is usually centered at the origin. Not always, but it is. If your vertex is at the origin, this is called standard position. Most of your angles will be in standard position. Pause. Actually, just let it roll, I guess. Who cares? The first equation here, and then a perk down here. You're solving for P. P is the number. How much should I start with? That's what you're looking for. Is the P value. To get 25. That's right. That's right.
And that one.
Now, there are some other things about geometry, technically.
Oh no.
Okay? With just real easy things. Simple things.
Better than
Complementary angles.
Angles that add up to 90.
Oh, that's correct. And how do you memorize the fact that it's 90 and not 180?
Because supplementary is supplementary. I don't know.
Supplementary super. Super means all of it. That's what I'm going to go with.
Here's what I'm going to go with. Mr. Jones?
What's up?
C and S, which one comes first in the alphabet? C, right?
Man, I don't know.
And which means, since C comes first, 90 comes first when you count. Fair enough? S comes second in the alphabet. These are two angles that add up to 180. 180 comes second when you count. Fair enough? Now, here's what we can also put on here. if I go all the way around the circle, we know that this is going to be 360 degrees. We know that this is going to be 360 degrees. If I go all the way around the circle, I am telling you that it is also the same as 2 pi. 2 pi. Now, Mr. Jones.
I make a better circle than you deal with it.
Mr. Jones, I want to give you a key point. Okay? And here's what we have to remember. Listen to me very closely. 2 degrees. That is a
quick question.
Yeah, go ahead.
Like, this is like totally different than what we're doing right here, right?
Correct.
So it's
brand
like,
new
so it's
topics.
Like a new start.
Brand new start. Clean slate. Different part of the brain. 2 degrees is absolutely not the same as 2 radians. Those are not equal. People will tell you that they are, but they are not the same. Not even close to being the same. Because if you write it this way, think about this. 2 pi, remember 1 pi is 3.14 blah blah blah, and if you double it, 3.14 becomes 6.28. This is the same as 6.28 radians. So question, how much is 2 radians going to be? Say it again. Look, all the way around is 6, right? So here's about 1, 2, 3, 4, 5, 6, about that. So 1, 2 is maybe right at about here. Maybe 100, 110, 120 degrees, somewhere in there. We'll convert it in a little while, and I'll show you how to figure it out. What's up? All set? Yeah, just set it right there. It's fine. Okay. What else do we have here? Give me a 78-degree angle. We have something that is called coterminal. Now, what did I tell you is the coterminal side? Coterminal side is right up here. Or the terminal side is right up here.
So coterminal and terminal are...
No, watch. I'll show you.
Okay.
Watch. How many angles are there that have this terminal side?
What?
How many angles are there that have this exact terminal side? 1. 1, you're wrong.
Wait.
Infinitely many. Because what I'm going to say is that I can have this terminal side, I can go all around the circle again, it lands here, I can go all around the circle again, or 10 times, or 100 times, or infinitely many times, and I can have the same exact angle. So, Walker, a coterminal angle would be to take my 78 degrees, and I could add 360 to it. And whatever that might be, we could say 418 degrees. No, that's not right. It's 438, isn't it? Oh, you're good. We're just reviewing here, simple stuff. What I could do is I could take 78 degrees and add to it 360 plus another 360. Right? Would that be 798? Okay?
Why are you doing that?
Because we are finding coterminal angles. 78 and 438 and 798 are the same exact angle, right?
So is it
All I did was add 360, go around the circle again.
Is it
So
terminal
it just lands
side
on the same spot, doesn't
any
it?
Correct.
angle that's that way, or does it have to be 78 degrees?
Oh, no, it could be any. My angle could come down here, it could come over here, it could be 1 degree. Okay, anything. Here's a general form in how to find that. Take your angle theta, the Greek letter theta. And what you could do is add to it 360. And you would get a coterminal angle, right? I could add to it 360 again and get another coterminal angle, right? I could add to it 360 plus 360 plus 360. Or I could subtract 360, right? If I went this direction and landed here, wouldn't that be the same angle?
Yeah.
Yes. So what I can do is take my angle theta and add to it 360 times any natural number n. And this would give you any coterminal angle.
What if you did theta minus 360?
That's fine. N would be a negative number.
You just put plus minus there?
Nah.
360.
No, because n is an integer, it could be -1. And if that's -1, it'd be theta plus -360, which is the same thing. Or, even easier, we could say theta plus 2 pi n if you are in radians, because 2 pi and 360 are the same. Oh, we're going to make another one. Okay, it's going to be more in depth and more detailed, and it's going to be better for us to use. Now, here's what I want to say. We have something called circumference. So, geometers. Okay, go ahead and turn that on. What is the formula for the circumference of a circle? That's area.
Pi times diameter.
That pi d, that's correct. And if I were to say pi d, I'm going to write this over here, Mr. Jacobs, because there's an easier way that I want to write it for today. What is diameter the same as?
2r.
2 radii. 2 pi r.
Aw, dang it.
Pi r squared is the area. So, if I note that the circumference is 2 pi r, we have something called the unit circle, which we love. And the word unit means what number? The word unit means what number? Number 1. And if the word unit means number 1, that means the radius of my unit circle is equal to 1. So what is the circumference of a circle with radius equal to 1? 2 pi is right. Because what I had was 2 times pi times 1. So the circumference is equal to 2 pi. And here's my proof to you. I'm going to prove to you this. If the circumference is equal to 2 pi, what is the definition of circumference? What does circumference mean to you? 360 degrees, this is round, right? So if I go all the way around one time, that's the circumference of this circle. And if the circumference is all the way around this circle, the distance around this circle is 2 times pi times r. The radius of the circle is 1, so the distance around the circle is 2 pi, which is also the same as 360 degrees.
Mind-blowing. Yes.
Now, I'm going to give you a quick list, and then we're going to postpone the rest tomorrow, of the radians and degrees that I would recommend that you memorize. Because I want to have a basis for all these. Okay, if you're finishing your test, this is going to be online by lunchtime, okay? Now, question. If 2 pi is all the way around one circle, also known as tau, did I show you the tau video last year?
No.
We'll do it again later. That is mind-blowing. That will create havoc in this classroom. No, I will. It'll be your nice little Christmas present before the break. If 2 pi is all the way around the circle, which is 360 degrees, King, what is 1 pi equal to? 1 pi is half the circle, or 180 degrees. Memorize it. And if pi is half the circle, what is half of the circle? 90 degrees, or 1/4 of the circle. 90 degrees, also known as pi over 2. Memorize it. And if 3/2 of the circle is 3 times 90 degrees, or 3/4 of the circle, that would be 3 pi over 2 would be 270 degrees. Because 270 is 3/4 of the circle. Right, Williams?
No.
Memorize it. We have 3 more.
Pi
Half of a half of a half.
Pi over 4.
Yeah, that's correct. Pi over 4. Think about it like this. Okay? All the way around is 2 pi. Halfway is 1 pi. Half of that is pi over 2. And half of that would be pi over 4. So pi over 4 is the same as what?
45.
Degrees.
No, I'm
Oh, okay.
It's 3/4 of the circle.
No.
Finally, we have 2 more. Pi over 6 and pi over 3, which I want you to memorize. They are flip-flopped. The numbers are flip-flopped. Pi over 6 is a smaller number, right? And since pi over 6 is a smaller number, we need the smaller angle, which is 30. Pi over 3 is a larger number, right? Which is going to be equal to 60. Think of it as pi over 6 doubled is 2 pi over 6. Okay?
No homework?
We can't, because I'm only halfway done. I got to finish the rest of this half tomorrow.
Smiley
Okay? And then we'll do some in-class work.
Winky, tongue out, smiley
How do you
face.
stop it? Without the
Actually, I'm going to leave for lunch.